So today I will discuss about how you can use GMDH for prediction as well as for optimization. Our first step will be to prepare the Excel datasheet. So we create a new Excel sheet, and for example, let us say we want to predict something with the help of GMDH software. So let us say I want to predict runoff with the help of rainfall and temperature. Okay. So I will take some arbitrary values. Temperature is 28 and runoff is 8. So I am taking some arbitrary value for both rainfall and rainfall, temperature, and runoff. Okay. So these are all the arbitrary values. Nothing real in it or such. So I want to predict runoff with the help of rainfall and temperature with the help of GMDH software. So we have to download the GMDH software from GMDH shell. This is the site, you see, gmdhsoftware.com. gmdhsoftware.com. From here you have to download it. We have the full version in our lab, so you can just install the software and use my serial number. So now after installing and activating the software, the first thing is you have to open it by clicking on the icon. This is the icon you can see. Now go to new. From there, CSV XLS XLSX connection. Click on it. And before opening the Excel sheet, kindly save the Excel sheet because otherwise it will not open. So then let us save it in the Excel. Okay, in the Excel here, Excel folder. You can save it in any folder of your wish. So this is the software. I have saved it as the name book 1. So just select the software, select the Excel sheet, and this will come. Okay. So then you just you have to do nothing here. So these are all by default is selected. Click OK. Now we want to forecast. So there are different types of jobs you can do with this software. So for this purpose, you select regression. Regression means regression using the regression type neural network regression. Now the software will ask you to identify the variable which you want to predict. So I want to predict the runoff, so I am selecting it. Then it will ask you to select the input variable. So why this rainfall is not being activated is at the time of importing there is some error. So what I will do is we will cancel it and we will again try to import the file. Right. So here you see we go on to the option and here you see use column 1 from beginning. So just select this one, 1, 2, 3. So these are basically, the software is asking you to identify the heading, row, and the ID of the rows. So these are very, generally they are, you must keep them as it is. But yes, if there is any problem, as we have seen, so you just change this value. You see column levels. Column levels means this one, rainfall, temperature. So in the row where you have given the headings of the column, you just select that row. If you have kept your heading in the second row, then you just go with this 2. If it is in the first row, then you go with first, right? And here also you have to indicate a ID field. So it is better to select this one, 1, 2, 3, and nothing else. No other thing. Sometimes what happens is some data is missing within this data set. So you can say, you can direct the software what to do with it, but it is better to keep it as it is. Okay, so then after this, click on OK, select regression and click OK. Now you see this rainfall list. Right, so I want to predict runoff. Runoff is selected. I want to predict input. With the help of the input, rainfall and temperature. I want to predict runoff with the help of rainfall and temperature. Okay. Now, in case of neural network is developed with the help of available data of input and output, which is also known as a training data set, by which neural network try to understand the problem. And here within the data set, you have to identify 2 different types of data. Suppose you have a data set which have 100 rows of data. Within these 100 rows, you may use 80% of the row for training or for developing the model, and 20% of the rows for testing the model. What is testing? Testing means in the training phase or training data, the model needs both input and output data to learn the problem, to develop the model. If it doesn't know what is the output and what is the input, then it cannot develop the model. So that is why you need a row of data set which has both the input and output. And after the model developed itself, what you will do is you will require a part of that data set where we know what is the output, we know what is the input, but model doesn't know about the interrelationship of the input and output of those part of data. So to test the developed model, we use that part of data to test the model. As model do not knows about that part of data, so it is unknown, the model is unknown to that data. So that is why if the model can predict that data also with the desired level of accuracy, then we can assume that the model has developed itself. So for that testing part, this testing part is also known as validation part, by which we validate the model. So what we are doing is, among these 21 rows of data that we have, 20% of that data is kept aside for validating the model or for testing the model. So it may be 20%, by rule of thumb is 20%, but you can use 10%. Okay. So here, as the data row is very small, 21, so I am using the 10% of the observation as validation. now we have indicated what is output, we have indicated what is input. Now we have also set aside the testing data set for testing the model, that is 10%. As a smaller the number of data set, smaller will be the percentage, because you need to provide the model with more larger number of data set for training itself. So, so this part is over. Now here, this is an interesting thing that is displayed here. These are different training algorithms that the model, that software has utilized to train the model. Here you can use these 4 different types of training algorithms, like combinatorial, quick combinatorial training algorithm, stepwise forward selection training algorithm, stepwise mixed selection training algorithm, and of course GMDH neural network training algorithms. As you know that this GMDH has a specialty, it can self-train itself. That means uh, you do not need to indicate how many number of hidden layers it has to generate, or how many number of uh, data set it must use to train itself, or how to update the weights. All the required parameters that a neural network needs to train itself, needs to determine itself with the help of this training. In case of GMDS, all those are automatically selected. So no need to use all those, no need to indicate all those parameters in this software. So here if you finish it, here you can see that this is the result. Now red one is showing the prediction, as we have used 10% of data for validation. So this is the 10% of data. 10% of 21 data is this much. So these 3 data points are used for testing, and this is the data point which is used for training. In this line, actually it shows both the actual data and the predicted data. You can see that. You can see this is the actual data, the data that we have provided to the model. This is the model fit, or the predicted data. This data is predicted by the GMP software. As the data set is very small, only 21, that is why the accuracy level is so high, it is nearly 100%. But this is the actual data and predicted data based on the training data. This part is training. So the model has developed itself with the help of this part. Now, model doesn't know about this part. Okay. This part the model doesn't know. So the model is validated with this part of data. And here also we see that model has performed fantastically. So if you want to know what amount of accuracy it has, click on this accuracy tab, and you can find what is the number of observations, that means how many training data you have given. 19 means 19 rows of data was used for training the model, and 2 rows was used for validating the model. And this is the maximum negative error, this is the maximum positive error, this is the mean absolute error, this is root mean square error, this is residual, standard deviation, coefficient of determination, and correlation. These are the statistical indices by which it is representing, or it is indicating the accuracy of the model, how well the model has done. So we will say what is maximum negative error. This is nothing but the subtraction of actual data from the predicted data. If model has over predicted, it will have a minus. Model has under predicted, it will have a plus. What is the difference between under prediction and over prediction? It is, suppose actual data is 10, but the model predicts it 11. So 10 minus 11, the formula is actual minus predicted. So 10 minus 11 is minus 1. So that become over trading. If the model predicted the same output as 9, so actual minus predicted is 10 minus 9, 1. So that is not minus 1 but 1, which indicates that model has under predicted the output. So if it is over predicted, it becomes minus. If it is under predicted, it becomes plus. So there is no difference of accuracy for over or under prediction. The main objective is the difference between actual data and the predicted data must be minimum. And it is best if it is 0, but if it is okay if it is between minus 1 to plus 1. So here all the data is in the e to the power minus 13. That means uh, it has a 10 to the power minus 13 of 1. That means it's a very good accuracy level. So this is maximum negative error means maximum over training. Maximum positive error means maximum under training. And mean absolute error is nothing but without the sign. Actual minus predicted without the sign. That means absolute value of actual data minus predicted data. Root mean square error is root over of the square of this difference. That means actual minus predicted whole square uh, means square root of this uh, error square. That means you say, let us say, so take a new code here. So you can say that uh, if it is so let us see the difference, so, suppose if this is the actual data minus predicted, okay, so if it is less than 0, that means P is greater than actual data, so this is known as over training. But for opposite it is known as under training. And this is also known as negative error, and this is also known as positive error. Okay. Now the next thing is mean absolute error. It is nothing but the absolute minus predicted, the absolute value of absolute minus predicted. This is your mean, and yes, why mean is coming? Mean is given because, as you see, I have used 21 number of data rows to develop the model. So this actual minus predicted will be there for 21 data rows, because in this 21 data row there will be 21 number of output, actual output, and 21 number of predicted output. So there will be 21 number of A minus B, and which can A minus B, and when you use this sign, absolute sign or mod sign, so this is an unsigned error. Here we are using sign, here we are not using sign, so it is an unsigned error. So, so this error will be, there will be 21 number of different errors for the 21 number of data rows. So when we do, or when we try to find the mean absolute error, it is nothing but the average value of A minus B mod for each of the data row 1 to n. That means you have to find the error for each of the data row from 1 to 21, and you have to evaluate it. That means you have to add the errors and you have to divide it by 20. So this will give you mean or average absolute error. This is your error, actual minus predicted, and this is when you use this mod, then there will be no sign there. So this becomes your absolute error when you are using this mod sign, and when you are averaging this absolute error becomes mean absolute error. Now what is relative mean square error? Relative mean square error is actually when you square this term a minus b whole square, and then you add this term. That means there will be 21 number of a minus b. So if you add them, and then average, then divide them by 21. As there is a 21 number of data row, you will divide it by 21, and then you make the square root. It becomes root mean square error. So in summary, you can say that root mean square error is the average of error square, or root mean square error is equals to the square root of average of the square of errors, right? So what we have to do is we have to subtract actual value from with predicted value, or predicted value from the actual value. We have to square it and add with the other error square, and then we have to average it by dividing it by 21, as there is a 21 number of data sets. If there are 100 data sets, then you will use 100. The main thing is you have to average it, and then you have to square root it to find the root mean square error. So now you'll ask that what is the difference between mean absolute error and RMAC, root mean square error. And I will say mean absolute error is neglecting the sign with the help of mod, And root mean square error is neglecting the sign by squaring the error and taking the average. So this is the basic two difference here. Now, if I say that what is correlation or what is R square? So this R square indicates the relationship between the actual output and the predicted output. So this is basically the relationship between actual output and predicted output. So this is best when it is equals to 1, but nearer to 1 is also accepted. But if it reduces or it becomes near to 0, then it is not accepted. 0 indicates no relation between the actual output and predicted output, and 1 indicates 100% relation. So, as I was discussing, R square, it must be nearer to 1, which indicates 100% relationship. And if it is nearer to 0, it indicates no relationship. In between this, it varies with the relationship between the actual output and predicted output. So these are few metrics. This RMAC, mean absolute error, then you positive error, negative error, R square. These all are known as statistical indices or performance metrics. Always note that lesser the RMAC, lesser the mean absolute error, lesser the positive error, lesser the negative error, better is the model, more accurate is the developed model. And larger the R square, as I already discussed, more near to 1, more accuracy or more reliability to the developed model. So we always prefer the model which have a very high R square, exactly equals to 1 or nearly equals to 1, and a very low RMAC, mean absolute error, this positive error, negative error. Okay? So always note that. So here you see all these things are very low, minus this e to the power minus 13. So it's a very small term, and so the error is very low, positive error is very low, mean absolute error is very low, RMAC is very low, residual sum is also very low, standard deviation is need to be near to 1, but here it is 2.80, that's okay. And coefficient of determination R square that I already discussed, you see this is absolute result. This very good result is due to the very less number of data set that I have used to develop the model. Here they will also give you the raw model equation. This equation you can use to predict the data. Or what you can do is you can just export this model into Excel and you can predict your data set. Suppose you are exporting, current means the current output only. So you just click OK. You see the model has been exported. I think there is some problem in the Excel sheet. So let us try again. think there is some problem in my Excel software. So more or less, if you use this export term and then the raw model term and then you select this spreadsheet formula, then the entire model data is exported into the Excel sheet, which you can later use for prediction. So this is all about the prediction by GMDH. There are some more other issues like what is this? You can increase or decrease number of input variables and output variables. Output is referred as target variable here. And this thing that is rainfall keyword, temperature keyword, this indicates that some transformation of the input variable has been used by the GMDH model at the time of training. So these are done by the GMDH itself. You do not need to do anything around that. It is automatically done by the GMDH. So this is more or less what prediction by GMDH is. Now we have already discussed about the forecasting. Now let us discuss about optimization. How to optimize with GMDH. Suppose this first column stores the values of x and the second column stores the values of y. Okay, and y is the output variable that we want to optimize. So, and this is the x. How we want to optimize y? By changing x. Okay, and x is known as design variables. So let us say y is equal to x squared. This is the objective equation that we are using. So what we will do is here, and there is constants also. X cannot be equal to 1 or 2. It must be above 1. That is the lower constant or lower bound is 1 and higher bound is 2. Higher constant or higher bound. So how do we do this in Excel? So what we do is, that means x can have a value in between 1 or 1 to 2, but not equals to 1, not equals to 2. So how to do this in Excel? Just use this equals to, and then this will be your lower constant, that means 1, then we use this plus, then higher constant minus lower constant, then multiply it, use a star button to multiply with this random function. This is the formula for random function. Random function means when you iterate it, this rand in bracket will generate any value within 0 to 1. So as you can see, this is your 1.67282, right? This is generated value. It is more than 1, less than 2, right? And as y is equals to x squared, so it is automatically using this objective equation. Now our aim is to optimize. So we want to maximize this equation. So what we do, we just place this. So just need to understood. Here D2 and E2 is 1 and 2. Here no value for D2 to E2. But when we are copying this cell, the formula, it is showing as, it is referring to this D2, E2. So when I am copying it, it is automatically becoming D3, E3, D3. But there is no value here. So what you do is, either you can just copy this one also. Right, you see the values are coming. Okay, you can do this, or what you can do is you can simply use the term dollar. Once you use the term dollar here, even if you copy the cell, the, what I would say, the row number will not change. So you can see if I do this, you see the row number is not changing. If I put the dollar before D, then it will not change the column number, even if we copy it in other columns. Okay, let us see. Now I am copying it. Now I am copying this column to here. You see, this is sorry. If I copy this column into here, you see this is D2, but this is E. So the column is changed. But if I use this dollar sign here, then it is like this. You see, it is staying as it is. So what I have to do is, let us use this dollar sign before the row number, such that the row number doesn't change, even if I copy the formula across the row. And then once you use this dollar sign, what will happen is you can just delete this, and you see the same thing will happen, because all these rows now refer to D2 and D2. So here, so our data is already prepared, the data for training the model. So we will use another sheet for this, because GMDH need the data without any formula inherent to the cell. No formula must be pasted in the data sheet used by GMDH. That is why I removed the formula by using the paste special command. When you use the paste special command, then even if you copy the formula cells, all the values will be copied or pasted. Your formulas will not be pasted if you use your paste special command. That is paste number command. Let me show you this one. Paste only values. Right? Now this sheet has the data with formula, and this sheet has the data without formula that I have used by using the paste values command, or paste 1, 2, 3 command, whatever you understand. Okay. So now we will import this data set into the what is it? Using GMDH. Go to new, click on CSV, and then select this root one. And you see here also they will ask about the hidden column and all this thing. So I am saying that columns level is given in the first row. So it is automatically selected the first row where I have written X and Y. And row levels, I am saying that by default you use just 1, 2, 3 as row level or ID, as this is not very important in this case. Then select duration, and then just same as thing, which value like to predict. Yes, I will like to predict Y. Which variable will be the input? X. Next, 10% of the data for training and testing or validation, then tested it. As the number of data is very slow, very small, high accurate data, accurate result, finish it off. You see, this is the accuracy level. Negative error is minus, that means overtraining, but very small difference. between actual and prediction. Positive error under training, but very small value of difference. Mean absolute error, very small, e to the power minus 40. You can imagine how small that difference is. RMSE, very small. However, R square is exactly 1. Correlation is exactly 1. These two are basically same thing. Now, what is the standard deviation? This is the standard deviation means that the deviation from the mean for each of the data and its average. So, for example, let us go to our drawing chart. So, for example, suppose there is a data like this 3, 2, 1. Then what is the mean? 5, 6, 4, 5, 6. 6 divided by 3. Mean means average. So the mean is 2, this one. So this 3 is plus 1, this 1 is minus 1. This is the deviation. Okay, so this is the exported Excel sheet from the GMDH, from the GMDH software. You can do it by clicking on the export tab, then to raw model, then to spreadsheet formula. And they will say whether to export the current or the earlier models or all the models. You select current and click on OK. Then what will happen? This Excel sheet will be generated. This yellow column is actually the predicted, and this Y is your actual data. Now in our optimization problem, this is a maximization problem. So we will try to find out where Y is maximum. So what I see here, the Y is maximum. I have used on a simple formula of Excel, maximum value of this column. It has said 3.959 and this 3.959 is here. So this is your 3.959. This row is your optimal row where for a value of X, Y is giving the maximum value. So the optimal value of the design variable is 1.98. So it is decided that at 1.98, Y will give the maximum value. So here you see that although we are using the objective equation here, but sometimes it happens that we cannot use the objective equation like this. But when we develop the GMDH model, the objective equation will be developed and can be used like this. So after the objective equation is developed and you export the model, you can generate any number of values you want for your input value. So suppose here is only 45 data. So you can use this, just copy this row, and as many row you copy, as many data it will generate. But before that, what you have to do is you have to use the formula that you are using to generate these input values. That means this formula, this lower bound plus upper bound minus lower bound multiplied by that. We have to use this formula here. So just paste it out. No need to use this D2 and all this thing, just use directly the minimum value 1, directly the minimum value and maximum value 2 minus 1, and when keep random as it is, then just select this, and you have more number of data. In case of optimization, larger the data you iterate, more accurate result you can expect. So each of these row is actually your iteration. So Here we have nearly 706 rows. So for 706 input, it has given 706 output, among which you have to identify which one is the maximum, right? So if you want to use 1000 number of iteration, then just select the model, select the row and copy it like this as I am showing you. And yes, you have your 1000 data generated, right? So now you try to find the maximum out of this 1000 number of outputs. So each of these row is a iteration. Now just change this from the max. There is C to C45 here. Just put the updated cell reference here. It's 1001 now. And click here. So the maximum value is now you see 3.9. So more you iterate, more better result you can expect from your optimization. So here with the help of GMDH, what is the advantage is that sometimes objective equation cannot be determined like this as in the example I am showing. It is not so easy. So in that cases, GMDH can be used for developing that equation. And when you export that equation into the Excel sheet, you can generate as many number of data rows as you wish. And remember that in optimization, each row of the sheet is a iteration. And more the number of rows you generate, more accurate result you can expect from the optimization. Right? So here it is 3.98. So you have to find out where is the 3.98. So let us see. So it is very difficult to find the maximum value from here with so many data you have. So for this you can use the conditional formatting of cell by Excel. So we use this, select that column, go to conditional formatting, then go to data parts, anything, color scale, anything. So you select this one, right? Or you can select anything, color scale, anything you wish, you can select, right? So let us select this one, top bottom rules. So I want the maximum values. So let us select this top 10 values. So we have done it. So within this top 10, we can select only the first value, the maximum value here, which will be shown in a different color. So click OK and just check where is that different color cell. So no need. So just zoom out and check where is the zoom. So at the 602nd iteration, we have the maximum value. So you see, it is very easy to do optimization in GMDH. And for more complex optimization, the result will be more better compared to the other optimization